Okay, we're going to now discuss limit 7. All these problems will be 0 over 0. They're going to represent wholes, and you're going to have to now rationalize. Before we begin, the crux of today's sheet is understanding the difference of squares. When you multiply two conjugates together, what does it mean to be a conjugate? It means that the first and second terms are exactly alike, except they're separated, one with a positive and one with a negative, and this always yields a difference of squares. So you're used to having to multiply the conjugates and get a difference of squares, and when you have a difference of squares, you factor them into the square roots of the conjugates. Now, we will be using the conjugate of f minus L every single time, which will be f plus L, to rationalize the numerator most of the time, but the denominator when necessary. In Algebra 2, I'm going to do a couple of examples of what you did. You only rationalized, for the most part, denominators. Okay, it was good practice. So I see 5 minus root 3. Its conjugate's 5 plus root 3. So I used my form of 1, my unit multiplier, to unreduce, so to speak. In the denominator, you would automatically distribute. You know that it's either first times first and last times last, or you just do the squares of each and put a minus. On the top, we always distributed, and we went on and combined. What we're going to find out today is we're going to do the distributing, but we are not going to actually multiply the numerator or denominator, whichever one is being left behind, okay? So let's review this algebraic process. First, you have to find out where the radical is going to be, and then you're going to rationalize using the conjugate as a form of 1, that is a unit multiplier. You'll distribute the conjugate and always get your f squared minus L squared. You will leave the other portion, whether it's the numerator or denominator, factored. If necessary, the distributed portion you will simplify, and then you'll reduce the fraction. The result of reducing the fraction will reduce the whole, which is the bane of our existence and why we're 0 over 0 to begin with. We will then be able to evaluate the said limit. So, here we go. I give you this. I see the radicals in the numerator, so I use the conjugate of square root x minus 2, which is square root x plus 2. I distribute only the numerator. Notice it's a difference of squares. X square root x squared is x, and 2 squared is 4, or first times first is x, and last times last is 4. I leave the denominator factored. I'm then able to cancel the x minus 4's, and there is my final answer. That's the easy form. Now let's do a more complicated one. Radical still on top. So I need the conjugate, which is 6 plus. Notice I don't change either of the terms, just the sign in between. I distribute. Oh, but I have a binomial, and whenever you have a binomial, you must always have a parenthesis. Note the denominator is left in factored form. I went ahead and simplified the numerator, so that's 36 minus 39 plus x, which gives me negative 3 plus x, which is not exactly my denominator. So I factored out the negative, so I would have exactly my denominator, and I reduced. Yes, this is a lot of algebra, but it's necessary. It's a good review. To be successful in a math or science field in your life, you must have these great algebra skills. They must be superb. This is a skills exercise big time on this worksheet. So now we are ready to proceed and to do today's problem. They're all going to be a whole, so you're going to have to rationalize the numerator or denominator. The only problem we give you, I think, with the denominator is your very last one, using conjugates. You will then Simplify if necessary. I didn't put that in there. It's just an automatic factor, reduce, substitute. So let's start with the easy one. So here's my limit. When I put in 4, I end up with 0 over 0. Now, what does that mean when you get 0 over 0 when you plug in 4? Well, it means either x minus 4 or 4 minus x has to be the factor, because if 4 makes it 0, just think of this subtracting to the other side. X minus 4 is approaching 0. So I know that somewhere in that numerator is an x minus 4. So I rationalize my numerator. It's a minus, so I use the plus. I'm going to distribute. So when I multiply those, it's x minus 4. I leave the denominator factored. Wow, out came that x minus 4 as I knew it had to. And I reduce the x minus 4s, and I have 1 over. And now I'm ready to substitute, and I get 1 over square root 4 plus 2, which is 1 over 2 plus 2, which is 1/4. This is going to be our procedure as we continue, but we may need to simplify and or factor some of these. So my next example, here we go. I plug in my 25, and lo and behold, I get 0 over 0, which means more algebra. But what else does it mean? It means that if I move the 25 over, it's x minus 25 approaching 0. So that means x minus 25 or 25 minus x is a factor of both. So I rationalize the numerator. The minus becomes a plus. I distribute and get 25 minus x. I leave the denominator factored. Oh no, these don't match. Now for some of you, you're going to be able to see that those guys are opposites. And if you can, and how do you know they're opposites? If you add these two together, you get 0. And so you know they're opposites, and you can skip this step and go there. Others of you will never be comfortable with that. You want to see that they look exactly alike. And so you will factor the negative out, and now, oh wow, they're exactly alike. And then you can reduce, and you get negative 1 over 5 plus the square root of x. Substituting the 25, I get negative 1 over 5 plus the square root of 25, which becomes 5 plus 5, which becomes 10. So my final answer is negative 1/10. Next problem. I have this limit. I plug in my 0, and I get 0 over 0. Whoa, more algebra. What does this mean? X is a factor of both the numerator and the denominator. So I rationalize. I have to put in a plus. And now, it's a binomial, so I need my parenthesis when I multiply. Now that one was easy enough. I don't have to show the removing of the parenthesis. You really didn't need it there, so you can see the 3's cancel. I now have x over. I'm ready to reduce. It's 1 over. And now I plug in the 0, and the square root of 3 plus 0 is the square root of 3. And so square root 3 is 2 root 3. Now, in calculus, we usually leave the answer like that. But if it were a multiple choice test, put out by someone, they may go to rationalized form where you multiply by root 3 over root 3. But I kid you not, we just leave it that way. All right, onward. We have a few more problems we need to discuss as we go in. And so now, next problem. Here we go, put in the 0. What do I end up with? 0 over 0. So again, x is a factor of both. I rationalize. The subtract becomes a plus. I distribute 7. Yes, that's a binomial. So I need my parenthesis. And now I'm going to show the extra step. Normally I write this up above. But for this problem, 7 minus x minus 7, I simplify some more. I have negative x. I can now reduce. I have negative 1 over. I am ready to substitute. And sorry about that, I got a box in the way here. And when I'm ready to substitute, I'm going to get 0 plus 7, root 7, root 7, negative 1 over 2 root 7, leave it, or that could be the answer. For the next problem, again, I'm going to plug in my 4, and I end up with 0 over 0. That means that 4 minus x, or x minus 4, must be a factor of both. And so I distribute. It's a binomial. There's my parenthesis, but again, I don't need to finish the work because I can ignore it. I have x minus 4. The x minus 4's cancel. So I am now simply able to reduce and get 1. When I insert the 4, 4 plus 5 is 9, whose square root is 3. So my final answer is 1/6. Example 6. So I have the limit as x approaches 5. When I substitute my 5, again, I get 0 over 0. What does this mean? 5 minus x, or x minus 5, have to be a factor of both numerator and denominator. I am now ready to multiply by the conjugate. The minus gets the plus. I distribute. Notice I need the parenthesis because that's a binomial. And now notice when I simplify, rather than writing another step, I usually just show the work up above. It saves a line of writing, and that's very nice. And 4 minus x plus 1 becomes 5 minus x. So now I can reduce, and I have 1 over the quantity. I'm going to insert my 5. 5 minus 1 is 4, which becomes 2. And so my answer is 1/4. Have you noticed a pattern with the substitution? It would seem that the radical's value always becomes the value of the constant term that is not in the radical. Let's look over here. What was the constant term not in the radical here at the end? Root 7. Oh, wow, it became root 7. What was the value of the constant term here? 3. And what did the radical become? 3. What was the constant term in the radical down here? 2. And what did the square root become? 2. Voila. Voila. Walla walla bing bang. All right, that is always going to happen when you need to rationalize and you have 0 over 0 and you multiply by the conjugate. So last problem before we move to 1 in the denominator. So here we go. We insert our 2. 0 over 0. Yes, we need more algebra, and yes, x minus 2 or 2 minus x have to make both the numerator and denominator 0, and so they have to, that numerator needs to turn into one of those. So I'm going to rationalize. So here's the minus. I need the plus for the conjugate. I distribute. Yes, that's a binomial, so I need a parenthesis. Saving some room, I'm going to go ahead and show the simplifying up here. So I get negative 2 plus x. Some of you, again, will say, oh, wow, if I were to add those, I get 0, so you would go straight to this step. Others of you prefer to factor out the negative sign and have them exactly match. And now I have negative 1 over. And I go to insert. Let's watch it. I put in the 2, and it becomes a 25, and aha, there it is. It turns into the 5, and I have negative 1/10. Last problem. Yes, it can indeed appear in the denominator. There is a reason, which we'll discuss later, why it's usually in the numerator, but right now you can have it in the denominator. So when I have this problem, I insert my negative 3. I have 0 over 0, which means more algebra. So x plus 3 is a factor of both numerator and denominator. I have to use this particular term's conjugate because that's where the radical was. So this gets distributed and this gets left. When I distribute, yes, this was a binomial, so I need the parenthesis. On top, I leave it factored, again, because There's nothing to distribute there. I can ignore the parenthesis. And yes, the x plus 3's cancel. And so I'm just left with the term in the numerator. And watch it. I'm going to insert the -3. 4 minus 3. 1. There it is. Aha. 1. And we get 2. Now you should be able to be masters of this sheet.